Okay, so in this video, we're gonna look at how to name esters. In the previous video, I discussed in detail how carboxylic acids work, how their reactions are, how they're prepared, and how they react with alcohols to make esters, right? We understood how the structure of esters is and how do you basically figure out what compound is an ester and what compound is not an ester. Now, in this video, we will be focusing on naming those esters. Now, if you have made an ester out of an alcohol and carboxylic acid, how would you name that ester? That's what we're going to look at. So the very first thing here is going to be how an ester is formed, right? And I repeat that. So an ester, basically what an ester is and how it is formed, it is pretty simple. So at first you take an alcohol and then you add it to a carboxylic acid. Okay, and that would make an ester, right? So this would make an ester for you, and also produce one more thing, which is water. So this reaction, there's a condition for this reaction. It needs an acid, so you need H2SO4, and I told you that this reaction is also reversible. You can come back from an ester to alcohol and carboxylic acid as well. And also this reaction is called the condensation reaction, right? So this is condensation slash the esterification reaction. Now, in the previous video, I discussed in detail how an ester is formed, how the bonds are broken between a carboxylic acid and an alcohol, how they combine to form an ester, and how the water molecule comes out. If you guys want to watch the details, you guys can go back to my previous video to watch the details. Now, let me make an ester over here by using an alcohol. Okay, so let me take ethanoic. I'll take ethanoic acid as the carboxylic acid, right? So ethanoic acid, and I'll add it to ethanol. Okay, so a very simple example over here. So this would make some ester, which we have to name today, right? In this video, we're gonna name that. So ethanoic acid plus ethanol. We know ethanoic acid is what, C2H5. Okay, actually not C2H5. This mistake, you guys are also gonna make this mistake. In a carboxylic acid, the total number of carbons are counted when you include the COOH group, right? So here ethanoic acid has two carbons in total. So first it will have a CH3 and then it will have a COOH. Now this group is very important for the carboxylic acid. If you guys want to watch this video again, you guys can go back to my previous video, which is, I believe, lesson number 6 or lesson number 5, right? Okay, and then I add ethanol into it. So ethanol is C2H5OH, simple as that. This would make a carboxylic acid of the following formula: CH3, C double O, C2, C2H5 O, C2H5. Okay, so this would basically be it. So this is the name of the ester, right? C double O C2H5. That is the ester which this the reaction of this ethanoic acid and ethanol makes. Obviously, you add an acid over here to conduct this reaction. Now, how do you name this? That's the main purpose of this video, right? So I'm gonna show you how to name this just in a second. Right, so there's two things you have to keep in mind over here. Now the very first thing is, if you make the formula for this thing, okay, so I'm gonna bring this down. This is the ester. So it's something like this: CH3, C, then you have over here, then you have another over here, and then you have C, like this, okay, and then you just complete the hydrogens for each carbon. Notice over here I have not given any hydrogen to this carbon over here, okay, and there's a reason for that. I told you in the very first lesson that carbon has a valency of 4, right? It needs 4 electrons to complete its shell. Here it's the valency of the carbon is completed because 1 2 3 4, it already has 4 bonds. It doesn't need a hydrogen to actually stabilize the carbon atom. Okay, so that's why here there is no room for a hydrogen to be attached. Now how do you name this thing? This is an ester, and I told you what is a common depiction of an ester. It is this bond, right? And this is the bond which basically tells you that this is an ester and not a carboxylic acid, because if you notice in the carboxylic acid, it's the same sort of molecule. Okay, but you have over here C double O, and then you have this H over here, right? This H is basically making this whole molecule a carboxylic acid. But here what you have is C double O, but then you have a C. So if you have a C double O and then you have a C, that means it's an ester, it's not a carboxylic acid. That's the main difference between these both. You guys need to understand this difference. Now the next portion is, how do you basically find out the name of this thing, exactly the topic since the start. Now for that you need to keep in mind two things. Number one, the portion which is in front of this O. Now this O is very important, this O, right? The portion which is in front of this O, this portion comes from the alcohol you used. Okay, so here I used ethanol, so this comes from ethanol in this case. Okay, we understand that this whole chain, not the O, but this whole chain is coming from the alcohol, ethanol, right? And then we can also see this portion over here, this portion right here. So this portion right here, the portion to the left of the C, so this C is right here. So the portion to the left of the C, this whole chain including this C, I'm not going to exclude the C, I'm going to include it, this C, right? So the portion to the left of the C with the double bonded oxygen basically comes from the carboxylic acid you use. Okay, and that means that here the carboxylic acid I used was ethanoic acid. Okay, till now I believe this portion is clear. The portion which is in front of the C double bond, so whenever you find an ester, it can be like this, or it can also be depicted like this. Okay, so the oxygen can either be to the right or to the left, it depends how the examiner gives you the formula of the ester, right? So in this case, if you have a carbon over here and a carbon over here, then you need to recognize that this portion over here comes from the carboxylic acid, and this portion over here, this alone C, comes from an alcohol, right? So this is what you basically have to recognize. That's my purpose of telling this, right? Now you have recognized what alcohol you've used. You already know that, but you have recognized the part of the structure which is coming from the alcohol, and the part of the structure which is coming from the carboxylic acid. Now what you'll do is, now alcohol, you can see here alcohol comes after carboxylic acid in this case, where this is the most commonly used format, right? I'm going to tell you what I mean by format. You can also switch this up. You can also put this alcohol before the carboxylic acid, and then you can put the carboxylic acid, just like the example I drew below. In that case, this alcohol is going to be first and carboxylic acid is going to be the next, right? But the most commonly used format is this one, in which the carboxylic acid part is the first part and then the next part is the alcohol part. Now to name this, what you're going to do is you're going to write the alcohol part first, and then you're going to write the carboxylic acid part. Okay, so it's the reverse. Okay, so what did I use over here? I used ethanol, and for the carboxylic acid I used ethanoic acid. Okay, but this is not the complete name. You might be wondering, maybe this is the complete name, ethanol ethanoic acid. No, because this doesn't sound right. Ethanol ethanoic acid, they sound like two separate species, so I have to make it one species, because now this whole structure is one thing. It's not an alcohol and a carboxylic acid separate anymore, they're combined, right? So I'm gonna name it as, I'm gonna make slight changes. So for the alcohol part, I'm not gonna keep it ethanol, right? So I'm gonna remove this anol. I'm gonna remove this whole part, anol, and what I'm gonna replace it with is ethyl. So this is something new. So what I'm gonna do is, I literally remove this anol, okay, and I replaced it with ethyl. So I replace this anol with an yl. and the rest stays the same. Okay, that's for the carboxylic acid. That's for the alcohol, sorry. And for the carboxylic acid, what I'm going to do is I'm going to do the same thing which I did for the carboxylic acid, in which there was a metal attached, right? You remember the formula. If you don't know about this, you can go back to my previous video and watch that video about the carboxylic acids. It's explained in very much detail over there. So this thing, you changed the name of this thing. And how did you name this? I have explained it in my video prior to this one. So now ethanoic acid, now what you're going to do here is you're going to focus on this oic part. Okay, so for the alcohol I removed the an all, but for the carboxylic acid I'm going to remove this oic part and I'm going to change it to O8. Okay, so I'm changing oic to O8 and the rest stays the same. Okay, so the rest is going to stay the same, so it's going to say eth and O8. Okay, so now I'm going to combine these both. Okay, so they're not separate, they're one entity, so I'm going to write ethyl eth and O8. Okay, and that's what my carboxylic acid. This whole structure is now the ester which I drew over here. This whole is ethyl ethanoate, right? And that's how you name it. Now let's take another example. I'm going to do some practice questions so that it's very clear to you guys. So the number one example I'm going to take is, I'm also going to go do the reverse process. I'm going to write the name and then I'm going to write the formula for it so that it's clear by the reverse working as well. So the very first structure I'm going to make is CCC double bond O and then CH3, right? So something like this, and the empty bars are hydrogens basically. So how am I going to name it? So the first thing I'm going to do is basically separate the alcohol part and the carboxylic acid part. So I'm going to say this is my alcohol part because this is after the oxygen, and this is my carboxylic acid part because this is before the this whole including the carbon is my carboxylic acid part because it came before this oxygen here plays the most vital role, right? The single oxygen. In front of it is the alcohol part, before it is the carboxylic acid part. So now what am I gonna do is I'm gonna name this. I'm gonna say, okay, this alcohol has only one carbon, so what can it be? It can only be methanol. Okay, and then I'm gonna see how many carbons does this carboxylic acid have? 3. So what is the name of a 3 carbon carboxylic acid? It is propanoic acid. Okay, till here I'm done, right? If you're new to the naming of esters, you can do it this way, the way I'm doing it. But if you have a little bit of practice, you can actually keep these two names in your mind and then you can write the ultimate formula below it, right? So now I'm gonna say, okay, so how did I name esters? In the naming of esters, I put the alcohol part first and then the carboxylic acid part. So I'm gonna say, okay, the alcohol part is methanol. So I'm gonna remove this and all, and what I'm gonna replace it with is methyl. Okay, I explained it over here, and then comes the carboxylic acid part, and in the carboxylic acid part I'm going to remove this oic and I'm going to replace it with O8, right? So methyl prop and O8, that's it, no acid after it. So methyl propanoate is the name of this ester. Okay, now another ester I'm gonna draw over here, and it's gonna be a little confusing because I'm gonna change something up. So I'm gonna draw it like this. It's something like C C C C, and then also 2 C's over here. Okay, I'm gonna shift it a little to the right so it doesn't mess up. So this thing here, I'm gonna complete the carbon bonds, and here we go. The carbons are now completed, the blank bars of the hydrogens. Now I want you guys to think about it for a second and then name it appropriately, and then I'm gonna solve it for you. So I'm gonna give you 5 seconds to basically try to name it, right? Right. I hope you guys are done now. Yeah, so let's see how to name it. Now again, I have to point out 2 different groups in this thing. I have to point out, number one thing I have to point out is this oxygen, which is right in between of the double bonded carbon and then the next carbon, right? So this oxygen, I have to point this oxygen out because this oxygen plays a very important role. Now I told you before that the part to the right of this oxygen would be an alcohol, but in this case it won't be an alcohol because on the right of this oxygen is this carbon, the double bonded carbon. It's going to stop it from being an alcohol. Alcohol doesn't have a double bonded carbon to an oxygen, right? So in this case, we move to the left of this oxygen. The part which does not have a carbon to double bond oxygen is going to be my alcohol part, in simpler words. So this is my alcohol part. Now you're going to see how many carbons does it have? 2. So it's going to be an ethanol. Okay. And then I'm going to see this whole part comes from the carboxylic acid part, and I'm going to say, okay, so how many carbons does this have? 1, 2, 3, 4. Okay, cool. So 4 carbon carboxylic acid is a butanoic acid. Fair enough. And then you're going to say, okay, now I'm going to join these both, and I'm going to put this ethanol obviously at first. Now I'm not going to switch them, because in this case butanoic acid is coming after ethanol. So I'm not going to say, okay, so whatever comes after the first one is named first. No, the ester, the format of the name of an ester remains the same no matter how the structure is given. So in the naming, you have to write the alcohol part first and the acid part first. So in this case, we already have the alcohol part here, so I'm going to write it as ethyl, and I'm going to write this as butanoate. So that is the name of this ester. Okay, I hope this made sense. Third, now in this case, I'm gonna give you guys a name of an ester, and you guys have to draw it. So I'm gonna say butyl butanoate, right? So I'm going to draw this thing now, butyl butanoate. Now you have to draw it. You're not given with the structure, but instead you have to draw the structure. You're given with the name. Okay, it's pretty easy. The first thing you're going to draw is this part, butanoate part. Okay, so how do you draw the butanoate first? You draw it to the left hand side of your screen. So how are you going to do it? You know, this part comes from an acid, the butanoic acid. So what you're going to do is you're going to put the C double bond oxygen at the start, and then you're going to put another oxygen over here, and this, you know, is the pivotal oxygen, the very important oxygen, okay, which I also mentioned over here. Now you make this part first. Now once that, for every ester you make this part first, the next thing you do is you basically say, okay, so now this oxygen here, and to the left of this oxygen is a carbon double bonded oxygen, which means this part here is all going to be the carboxylic acid part, and this part here is all going to be my alcohol part. Okay, now once you understand this thing, then you just have to complete the name. So butanoate comes from what acid? Butanoic acid, right? So butanoic acid has 4 carbons. So now let's complete this structure to the left for the acid. So 4 carbons have to complete. So 1, 2, 3, 4 carbons done. That's my butanoate part done. The next part I'm going to complete is for the butyl part, and the butyl part is coming from an alcohol, which is a butanol, right? So for the butanol I have 4 carbons. Now to the right of this oxygen, so this is my carboxylic acid and this is my alcohol. So to the right of this oxygen I'm going to place 4 carbons, 1, 2, 3, 4. Okay, and that makes my ester butyl butanoate. Okay, so I hope this thing is clear by now. How you would be naming esters is pretty simple. I can give you a very last example, which is going to be the ultimate test for if you guys understand. So a structure can also be given like this. Okay, so a structure can be given like this as well, and I'm gonna just draw it like this. So like this, right? So structure can be given like this, and then also it can have an oxygen over here. I'll shift it a little downwards so it doesn't make a mess on my screen. So yeah, so this 4 also comes down here. Oh my god, okay, I'll just write it again. Alright, so now this part I can actually draw it again if it's not clear. So the ester, I'm gonna make it C double bond oxygen, and then C C C, and here I'm gonna put C and just this part. Okay, I'm sorry, I just did a mistake. Here I'm gonna put basically an oxygen and then a C. Okay, and I ask you guys to write the name of this thing, and also the bonds for the carbons with no double bonds is basically the hydrogen is gonna be fitting there. Now what is the name of this whole structure? Now by looking at it, you're gonna recognize the first step is to always point out the carboxylic acid part and the alcohol part. So you're gonna say this is my pivotal oxygen, and to the right of this oxygen is the carbon with the double bonded oxygen. So it means this part whole is my carboxylic acid part. Done. And then I'm going to say this part over here to the left of this oxygen is obviously my alcohol part. And then you're just going to name the alcohol. So this alcohol here is methanol because it has only one carbon. This carboxylic acid has 4 carbons, 1 2 3 4. You include this carbon, okay? And then you write butanoic acid, and this becomes, as a total, it becomes, the alcohol part comes first, so it becomes methyl butanoate. Okay, so that's also how you can be given with a structure and how you can name it. Now one last thing I want to draw is methyl methanoate. Okay, and if you're given the name, you have to draw it. The very first step I told you in the process of drawing this ester is basically making this structure, C double bond oxygen and then an oxygen. Now this structure is the pivotal structure. Now you're going to look at the carboxylic acid. Now you're going to say, okay, so this oxygen is my pivotal oxygen, and to the left I have a carbon with the double bonded oxygen, which means this portion whole over here is going to be my carboxylic acid part, and this portion whole over here is going to be my alcohol part, right? So I'm going to make it. How would I make it? I would just see, okay, what is the name of this ester given? So the methanoate part comes from the carboxylic acid, and the carboxylic acid in that case is going to be methanoic acid. Now remember one thing, methanoic acid has only one carbon, so you're going to say, okay, it has only one carbon, I can put one carbon over here. Okay, I can put one carbon to the left. No, that's wrong, because in this case, if you put this carbon over here, then when you rename it, now imagine this is a structure drawn to you and you have to rename it. How are you going to name this part? You're going to say, okay, 1 carbon, 2 carbon, that's not going to stay methanoic acid, that's going to be ethanoic acid, because you have to include this carbon in your naming. So which means that when you name for the carboxylic acid, you basically decrease it by 1 carbon. So this carbon is included in the name already. So methanoic acid has 1 carbon that is already present over here. The double bond oxygen carbon is already present over here. You don't need another carbon with it, and you just complete its bond. So you have to have 1 bond here. This carbon has 2 bonds with the oxygen, 1 2, 1 bond with this oxygen. It has 1 bond which is vacant, right? So we're going to put it hydrogen over here. If it's vacant, we put a hydrogen. And then to the right of this oxygen to the right of this oxygen, we put this group, which is the alcohol group. And methyl comes from methanol, which is 1 carbon alcohol, and it's just like this. Okay, so this structure as a complete is a structure of methyl methanoate. Now in your exams, now I haven't drawn the hydrogens over here. Make sure you draw these hydrogens over here. Okay, you name them. You're not gonna leave these bars as it is, and you're gonna write, like, you're not gonna leave this structure as it is. It is true, it is right, but you're gonna complete the structure by also completing the hydrogens over here. Not just the bars, you're also gonna write hydrogens, right? H. And then also it says in your exams, it explicitly mentions you have to draw the complete displayed formula. Now the displayed formula means that you have to show every bond. I can mention it over here. It is very important. So in your exams, you can be asked to draw the displayed formula. And for the displayed formula, you have to show every single bond. Okay, and when it says condensed formula, in that case you can omit showing a bond, right? So an example over here is an alcohol, right? I can take an alcohol as an example. So if it says me to draw a displayed formula of ethanol, for example, right? So what am I going to do? I'm going to say, okay, ethanol is C2H5OH, right? So I'm going to just make it 1 2, and then there comes the OH, and there comes the hydrogens. Now while you may think this is right, this is not right, because this is not the displayed formula. This might be the structural formula, or the condensed, this is not a condensed formula either, but it might be a structural formula, right? It's not a displayed formula for sure. Why? The reason is you have not showed the bond of oxygen and hydrogen over here. You have to show it. In the case of a displayed formula, you have to show this bond as well. Then only you'll get a mark. Otherwise, if you just write OH like you do randomly, If it doesn't ask for a display formula, then it's fine. If it does explicitly mention write the displayed formula of ethanol, then you have to write this OH in a separated way. You're not gonna write this. That's not a displayed formula. For a displayed formula, the OH needs to have, the OH actually has a bond, which you need to basically show the examiner that there is a bond between O and the hydrogen, which is a single bond, right? So in the displayed formula, you have to show each and every bond. That's just a little tip which I wanted to give you guys. Now this video I promised to be a 6 to 7 minutes video, but it actually got longer because I wasn't planning to do these examples, but I just thought it might be better to do it with the examples so that you guys have a better idea of how to name esters. Now I hope this video is clear to you and you guys can now name esters. I will see you guys in the next one.